I present to you my article entitled, Numerical Analysis of the Influence of Maximum Residual Thermal Stresses on the Intensity Factor between the Matrix and Particle Interfaces in Metal Matrix Composite. The Figure 1 shows the model of a structure composed of a matrix particle assembly. The Figure 3 reports the variation in maximum residual stress as a function of the crack particle interdistance. The Figure 4 shows the variation of the maximum residual stresses generated in the three directions of the matrix as a function of the crack widths. The results obtained in this part of the work show that under the effect of residual stress, a crack, initiated in the matrix, propagates in pure mode I when its front is located relatively far from the interface with the particle, and in mixed mode 1, 2 and 3 I when its front approaches this interface. This work centered on the analysis of the thermomechanical behavior of a composite cubic cell with a metal matrix. It should be noted that the maximum stresses in particle are at the bottom while those of the matrix are near at the bottom. This is mainly due to the interaction effect and difference of the mechanical properties of the materials. With regard to the S11 max and S22 max constraints, we note that the matrix supports the greatest load of these constraints. The increase in temperature gradient decreases the stresses. It should also be noted that the effect of the interdistance is significant for the load values of D and less than 0.4 micrometer for the two cases.